Yeah, thank you everyone for being back here, and great to continue here on. So Jake and I, we've been very fortunate to accompany the processes that we heard in the earlier presentations, with looking at what data is available on these topics and what these data can tell us. And there's two main avenues. For one, the data that's being collected is often very, very sparse and not done very often, and it's not done in all the areas that would be available. But there is still some conclusions that hold up scientifically and statistically, and that we would like to talk about today. And these analyses accompany two processes that are important: the dairy order and then the irrigated lands management program. And we're part of the Environmental Justice and the Common Good initiative on campus. We've been collaborating with CLLA for quite some time now, which has been wonderful. And we're both members of the Water and Climate Justice Lab, along with a lot of, and I want to just give a short shout out to all the students that have been working hard on getting water samples, testing these samples, supporting the analysis, and also supporting this meeting here today. And so we're going to talk on two things. One is, oh, I'm so sorry. So we're going to talk about two different aspects of this analysis. One is about identifying concentrated animal feeding operations, or CAFOs, in the Central Valley, and the opportunities and barriers and what that means for analyzing where the nitrate is coming from. And the other one is about contaminants and trends of contaminants on the Central Coast, and specifically on the communities that are also represented here and that we've been working with. So some of this will be updates, and some of it will be new steps at this point. So one of the things that we have done is to map where all the CAFOs are in the Central Valley, because the manure that they expel and store is a major source of concentrated nitrate in these places. And with all the spatial information that we have these days, we know where we can get our coffee, what time it's open, what it costs, whatnot, but there was no official layer on where these CAFOs are. So we've been working on this actually for probably a couple of years now, and we've also found out that we were not the only ones working on that. There have been two other efforts at the University of Michigan and at Stanford University. And but what we have done now in the meantime, they have come out with their publications. We have not only mapped them ourselves, but we've compared all these data sets, and now from all of these efforts, produced what we think is the most complete data set of all of the CAFOs in the Central Valley. And there's a total of 1,870. And they will play into follow-up analysis in a minute. We have also updated the interpolation maps of different contaminants in the Central Valley. So this comes from a data set, or several data sets. The main one is the gamma data set. And so these are measurements of contaminant concentrations in wells. And we're taking only the shallow wells, because that they tap the top layer in the shallow groundwater contamination where domestic wells take their water from. And unfortunately, there is relatively limited testing in terms of covering the whole area of the Central Valley, and also the frequency of the testing. But we have updated what we the data, collecting that data, and then interpolating between the wells. So interpolation is a statistical technique that gives the best estimate between actual well measurements. And then you can make, like maps like that, that gives the best possible estimate. And on this and the follow-up maps, we always, like what's at and above the MCL, the maximum contaminant level that is set by the EPA is in red. Then what's near the MCL is in orange. Half the MCL is to 3/4 is in yellow, and then below half the MCL is marked in green. So we have that for nitrate, and then we also have that for uranium. So uranium is less, there's less occurrence of that, but there's also many fewer measurements of uranium in the Central Valley. Uranium is actually also naturally occurring in sediments, but it becomes mobilized a lot of times by having different soil conditions that come with higher nitrate and fertilizers. So it is important to also look at other contaminants. And we heard the very moving testimony earlier about the many exposures that communities in farming communities have. So it's important to look at these as well. So then when we have these two different contaminants, we can also see where are people exposed to more than one, right? Where do these overlap? And so here we looked at where do nitrate and uranium overlap in the San Joaquin Valley. And the places on the map that are pink is where they both occur in concentrations that are higher than the maximum contaminant level. Thank you. I'm a little dense when it comes to the slowing down. The uranium only is orange on this map, and the red is only the nitrate. Okay, so I showed you earlier that we built this database of the CAFOs, but it's important not only to look at where are these CAFOs and how many do we have, but also what other information is there that might be nitrate relevant. Now, technically, the government is collecting that information, from these businesses that operate the CAFOs. But we now have these, electronic forms, you can fill in all the time. The way they give it to us, and this was only after a public records request from Leadership Council, is in PDFs, forms that you cannot automatically get the information from. You actually have to scrape it. And they only gave us 1 year and from 322 of these CAFOs. And on the earlier slide, I showed you there's actually more than 1,800, right? So they gave us less than a quarter in only 1 year. Interestingly enough, Stanford filed their own public records request, and they got a different set of PDFs. The person that's doing that was actually here last week. He couldn't come today. He really wishes to. But, we are going to be combining those, at least the information that we have so far. And so these PDFs, with our very hardworking students, we were able to scrape them. And they include data on the total animals, then also the wastewater generated, and the pounds of nitrate from manure and the total manure. So there's calculations one can do on how much nitrate is also put into the groundwater at these locations. So these are just examples on how we can map those. So the left map is wastewater, the center map is the total manure, and the size of the circle is the amount of the manure that is generated from a particular CAFO. So we could be zooming into those locations. And the right map is total animals. So some preliminary analysis of that, we can ask how does nitrate vary near CAFOs in different types of priority basins, like for the CV salts process, for example, right? So CV salts has priority 1 basins, priority 2, and then non-prioritized. So the 3 lines of this graph, the top one is the high priority, medium, and then no priority. And you see that, on the left side, it's very much near CAFOs. On the right side, it's further away from CAFOs. You can see that, how the nitrate is highest, closest to the CAFOs, and consistently above the MCL, far above the MCL in the priority 1 basins. So this is for the mean nitrate, the average nitrate, and the numbers are even higher when we look at the maximum nitrate levels that are measured, over time. Then we also analyze different census tracts, and we analyze the census tracts that have at least 1 CAFO in them, and they are 9.4 times as likely to have nitrate concentrations above the MCL than census tracts that don't have CAFOs, right? So this contamination is spreading out. And when we do kind of like a bivariate analysis on the impact for Latina communities with nitrate, so this is also based on census tract, we can make these kind of maps that show where nitrate is high and then where the percent of the Latina population is high, right? So, and then also where both of them are high. So if you read that legend down here, at the lower left, where both Latina populations are high and nitrate are high, this is where all the red is on the map. That's where that is occurring. And we see quite a bit on the map. So CAFOs are twice as likely to be present in census tracts where Latina residents make up at least 65% of the population, or 2/3. And I think this is
awesome. Yeah. Thank you, Iris, and a quick shout out. Thank you to my EMVS 188 students for joining us today. In addition to the analysis that we went through with all these dairies that are throughout the Central Valley, we also looked at new data that we've gotten since the last time we've all convened on Ag Order 4.0, which we learned about earlier this morning. And we have 2025 data, and we looked at how applied nitrate, so not nitrate from manure, from livestock, or from cattle, but from the fertilization is impacting groundwater. And in this case, we're a little closer to home right now in the Central Coast. So we already learned about kind of the legal battle timeline that's been going on with this issue, and it's been unfortunate. One of the biggest issues that us scientists kind of bang our heads against the wall is just the lack of data availability, as in the case of the CAFOs, and also fertilization rates, but also the lack of data transparency and reporting. So through another public records request, a recurring theme for our data analysis, Elias at CRLA helped us get 2025 data for all parcels that in theory should be throughout the entire Central Coast. That would give us information on what the total amount of applied nitrogen fertilizer there is from every source, as well as how much is removed and kind of the net, if it's a net surplus, net deficit, most of the time a surplus. And the 2025 data, which we got about a month and a half ago, is a huge improvement. There's 1,694 parcels that give us information on nitrogen fertilization rates and also on-farm domestic wells, because we are trying to demonstrate that we need to limit these fertilization rates to protect the safe drinking water throughout the Central Coast. Now, 1,694 is like a 5-fold increase from what we had in 2023 and 2024. So it seems like that's awesome. But if we look at all parcels that intersect with agricultural land, accounting for parcels that are mostly buildings, that's still less than 4% of the agricultural land that's reporting the amount, sorry about that, I'm going to slow down, the amount of excess nitrogen that's being discharged into our aquifer potentially. And here we have one of our communities, Pajaro. And near Pajaro, there's decent coverage when you look at the Central Coast as a whole, but there's still several areas where both the A-R values, so again, that's the surplus of nitrogen in pounds per acre, is very high. And if you look in the map, the deep blue is showing where also on-farm domestic well nitrate concentrations are extremely high as well. Another one of our communities, which is well represented today, is San Gerardo. And again, we don't have full coverage, but in this location, there are a number of farms where the nitrogen is above the safe limit. And the A-R values from these fields is extremely high, way above the target, way above any limit that we're hoping to establish. And the dark blue here, especially southeast of San Gerardo, has extremely high nitrogen concentrations in their wells, as well as a surplus of nitrogen discharge from all fertilization sources. We head a little further south in the Central Coast and throughout the Salinas Valley. We also have San Lucas, which probably has the worst coverage of A-R data and nitrogen contamination. Very few of the wells and fields are provided here. And unfortunately, this is where we're at in 2025. This is the Region 3 data from the Central Coast Water Board, and it's substantially better than what we get from the Central Valley. For example, we have acreage data where we're actually able to quantify this, whereas the whole San Joaquin Valley, we're not able to do that quantifying with acreage data. So when it comes to A-R values, we looked at the whole spread of the data set that we have, and we isolated the highest dischargers, so the ones that have the highest amount of A-R rates, and we looked at the top 30% versus the rest of the population. And when you look at that subset, the top 30% of the dischargers discharge 75% of the total amount of excess nitrogen into groundwater. This pattern is something that we know is occurring through time. So when we looked at the 21, 22, 23, 24 data over the past year before we got the 2025 data, we saw a similar share of this excess nitrogen being attributed to the biggest growers. So the total amount of pounds comes from a minority of the growers, oftentimes these larger factory farms. So no matter how you play with these numbers, and in the Water and Climate Justice Lab, we definitely know how to play with numbers. There's no way to say that this fertilization rate is not correlated with higher nitrogen values or nitrogen concentrations in our groundwater. The statistical graphic you see is a scatter plot with a linear regression line. With a moderate R-squared value, if you take the correlation coefficient, there's a 0.4 correlation showing that as you increase the amount of pounds per acre of excess nitrogen you have higher amounts of nitrate concentrations. And we've talked a lot about these limits throughout today, and I'm sure we will continue to talk about that. But we have evidence to show that limits could potentially, and not even potentially, but will reduce our water and make it safe for those residents. So looking at this threshold of 31 pounds per acre, we took our entire data set and we looked at, well, what is the well concentrations when we meet that target versus the ones that don't? And the graphic here on the left shows that the average nitrate concentration for the ones that don't are well above the MCL, close to 50% above the MCL. For the minority of fields that do have less than 31 pounds per acre, and again, this is from the 2025 data, the nitrate is actually at a fairly decent level, around 5 milligrams per liter. And this is very similar, again, to what we've seen in the years leading up to 2025. And I anticipate it's going to stay the same as we gather more data.
This is the interpreter speaking. Please, if we could slow down, especially when we're talking about results testing and analysis because we need to flip everything so that it can be understood in those languages. Thank you.
So again, sorry about that. I'm doing my best to. We applied the same interpolation method that Iris described, and that interpolation method is estimating points of unknown locations between points of known locations. And we have the same color scheme that we showed for the Central Valley here for the Central Coast. And we have widespread nitrate contamination above the MCL and near the MCL, where a lot of research shows is still harmful to those who drink it. The entire Salinas Valley is unfortunately has systemic widespread contamination, including a lot of the communities that were lucky enough to have representatives here today. San Nardo, San Lucas, San Gerardo, Pajaro, and then many locations throughout Salinas. And this is a subset that's not just an anomaly. We're looking at everything from January of 2010 to December of 2025, which is technically 16 years of data. So we're normalizing for any like spikes that could be potentially occurring. Unfortunately, nitrate is not the only groundwater contaminant in the Central Coast that is widespread systemic contamination. A pesticide, which a lot of you are probably familiar with, 1,2,3-TCP. We took the same set of data from the GeoTracker and Gamma databases at the state of California, and we modeled where the limits are safe versus unsafe. And as you can see here, it's really an unfortunate story if you're a Central Coast resident relying on a domestic well. TCP 123 has not as much nitrate data, but enough to show that it's extremely widespread, very dangerous levels throughout the entire Salinas Valley, including our communities that are here today. So those are two big contaminants that are impacting the quality and how safe the drinking water is throughout the Central Coast. And not to pile on more bad news, hexchromium is another contaminant that we're concerned with. Not as widespread throughout the entire Salinas Valley and Central Coast region, but in northern Monterey County, as well as southeastern Santa Cruz County, there's huge swaths of unsafe drinking water quality from hexavalent chromium, a specific chromium. And Pajaro, again, is kind of getting the short end of the stick when it comes to water quality. We didn't look at every contaminant, but we did also include arsenic. Arsenic has a lot of data collection similar to nitrate. Not ideal, but more than TCP 123 or the chromium. And we have, again, widespread areas of contamination where the water has excess arsenic, making it unsafe and causing, either acute or chronic health effects from drinking that water. If we look at it as a whole, and we have some of our communities highlighted here, there are locations where you're dealing with all four, particularly near Pajaro. Many of the communities here today have either 2 or 3 of the contaminants impacting, and there may be additional contamination. For example, manganese, iron, and nickel is widespread contamination across the Central Coast. And those are just other elements in our water that's making it unsafe for our domestic well users throughout the Central Coast. So we have all this data, and we've described how it's imperfect, and we know what it is in a window in time. But we also want to know, how are our data trending? Are things getting better? Are things getting worse? And again, we're focusing on these domestic wells. And unfortunately, greater than 70% of domestic wells, even with a 25-year sample, technically 26, January 2000 to December 31st, 2025, don't have enough well readings to even determine if the water is getting better or worse. And that is really alarming, because some of these wells will get tested, and they'll, let's say, get tested for all the contaminants we saw here. They're all unsafe. They don't get tested again for a decade. We just have a graphic here showing that we need at least 3 points to establish a trend, more to really draw any conclusions that are substantial. But the majority of our samples don't even meet that requirement. But I'm going to hand it now back to Iris. Thank you.
Yeah, so when we're then taking the wells that have enough data to calculate a trend, we find that 38 of the domestic wells had enough data to do that. And of these 38, 10 had significant trends. 7 of those were increasing, and 5 of those are increasing above the MCL. But also, you know, some good news, 3 of the wells were actually also decreasing in a significant way. The others, there was not enough data to tell either way, that it was not statistically significant. So this is for nitrate, and for the domestic wells, and then this map here is the same thing for monitoring wells. So monitoring wells, there are a lot more of them, and they often also have more, more testing data, but they might be at deeper, deeper in the aquifers, so they often don't tell the same story as the domestic wells. Of the 340 monitoring wells in the area, we had, for 340 monitoring wells, we had enough data to calculate these trends. And 68 had significant ones. Of these, 39 were increasing and 29 were decreasing in a statistically significant way. So what that means is there are areas that are getting worse, statistically significantly worse, and there are areas, though, where things are also getting better, and we need more of those, of course. And we need more data to actually determine that. And then I'd like to also wrap up with showing some results from a domestic well testing program that we have been doing with our amazing partners, CRLA, the Salinas office. So this is a study on where we have done seasonal well tests along the central coasts, with residents, because what we wanted to investigate is how much the nitrate and also the heavy metals vary during the year, right? If you only come every 5 years, maybe the test was done during a time when it's low, right? And other times the nitrate might be even higher. So we wanted to get a sense of how much nitrate is actually varying during a year. And you see here the 4 locations. 2 of those are always below the MCL, so that's really good news for those residents. So that definitely is also there, right? And we're glad to see that. And the other 2 are always above the MCL. And you see that there can be some ranges. Sometimes they're 4 times above the MCL, which is quite a bit. Other times they're more than 6 times above the MCL, which is very, very substantial. So I know we've talked a lot and much too fast. But you didn't put in.
I thought I had, actually.
Oh, maybe it didn't reload. One of the things is we wanted, in the next slide, we wanted to show the link to the story map that Elias was alluding to. But we'll get it in for the afternoon, I think. Yeah. Okay. Sounds good. So with that, we'll stop right here, and maybe we have time for a few questions. Yeah.
Okay, this is working, I think. Thank you so much, Jake and Iris and your students, for all your work over the years, doing PRA requests, Public Records Act requests, and then just scraping data and doing all of the late night analysis. I'm sure, Jake, you haven't had a lot of sleep in the last week or so, and just providing this incredibly important data and scientific foundation that sustains all of our advocacy together. I'm so grateful. So I wanted to ask one question from a few slides back on where you're comparing, I think wells that where farms are A-R is above 31 pounds per acre, and then comparing that to average milligrams per liter or nitrate concentrations. So I just wanted to clarify for myself, the data that you're using is from the Central Coast, right?
Correct.
But then the 31 pounds per acre target limit, is that from the Central Valley? So yeah, I just wanted to clarify for myself, since the limit or that was removed, the previous limit from the Act 4.0 was 50 pounds per acre, but I wanted to just make sure I understand.
Yeah. That was actually, that number actually came out of a coalition meeting a couple weeks ago. And so it was for the Central Coast. I unfortunately wasn't at that meeting. Do you remember?
So you're right that the data that we have to do this calculation is from the Central Coast, but the limit or target, the discussion at the coalition meeting was like, oh, you know, we actually want the 31 pounds per acre. So what would that look like? That's why we actually redid the analysis with that limit for the Central Valley, but the only data we have to do that is from the Central Coast. You're very good to pick up on this.
Creative. Thank you.
So the idea is, what would it look like, you know, if from the data that we have, if we parsed it along that limit, right? Even though it's not from the Central Valley, it's from another area.
Yeah. And I'm sure you have something, I think I actually remember working with you on where you did a similar chart, but with the 50 pounds per acre.
Yeah.
We had it in there with the 50 pounds and we changed it to that.
And I think it's similar, right?
It's very similar. This is the 2025 data, so we can definitely run it with the 50 pounds per acre, and I'm sure we'll have a similar trend, not trend, but similar relationship. But yeah.
Okay.
Absolutely.
That'd be great.
Yeah.
Thank you.
For sure.
I have a million questions. This was awesome, just as it was last year. The slide with the mapping of individual fields color-coded by AR and nitrogen concentration, this is exactly what the growers don't want us to be able to do. And so it's really exciting that we're beginning to use this data to start to drill down on.
And Horacio has been asking for that. I know.
I have a question about the lack of data coverage. Yeah. Were you asking for the INMPs or for TNA or for everything?
So they actually, through the public records request, we get like a huge spreadsheet, but they make you calculate it yourself. Like it's like a statistics lab or something. So to get all of that information, you have to actually do honestly, 9 or 10 calculations. So that's like a barrier to that information. You know, like that knowledge is not given out for free for some reason, even though it should be. But we were able to get total nitrogen applied by taking that A-R after we calculate it and multiplying it by ranch acres, which according to them is the number of acres that's actually growing. We noticed tons of inconsistencies. We've been very complimentary of the Central Coast in the past. With their data comparatively. I've cooled a little on that. Yeah, so we had the calculator, we got total nitrogen applied. As far as the coverage, they don't say, hey, we have this many. I had to take some statistical liberty. We had to take some statistical liberties. We looked at every parcel. that like intersects with what's considered agricultural land by the state of California. And then also removed any parcel that had like buildings covering more than like 60% of it. That's how we got to that, in my opinion, very conservative estimate that it's 3.8%. I wouldn't be shocked if it was like 1.7% or something of coverage.
Because we've all driven down 101 and we've all driven the back roads around Santa Clara, and we know there's a lot more ag than those
Exactly.
purple squares up there.